Hello students, this is video 3.10, 3.10. The unit title is Rooftop Triangles, and the objective is students will be able to use the Pythagorean theorem and its converse. The IXL skills are Q1 and Q2. All right, let's go flippers. So what we're learning today is about the Pythagorean theorem. So you probably know a lot about this, but we're going to be really specific as to what the Pythagorean theorem is. And what's really cool about this is that the Pythagorean theorem is actually a conditional statement. And it says, if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Okay, so I know that's very wordy, so let's kind of just break that down. So please draw a triangle or right triangle. Make sure you put the little right angle in the corner, and we're going to talk about specifically this part of the theorem. The theorem says, if a triangle is a right triangle, then the sum of the squares of the lengths of the legs. So the squares of the lengths of the legs. So let's find the legs in the triangle. Here they are. Here is a leg. We'll call this one A. And here's another leg. We'll call that one B. And in order to make squares of the legs, we actually have to create squares from these legs. There I've created two squares from the legs. So the leg and then it's square, and the leg and then a square. So the area of this particular square A would then be A squared. And the area of this particular leg here would be B squared. So this box here is A squared, and this box here is B squared. So now the rest of the theorem says is equal to the square of the length of the hypotenuse. So here's our hypotenuse. And if I were to draw a square off of that, I know you're thinking, oh, how can you draw a square? Yes, it would be a slanted square. And that's okay, as long as it's a square. Remember, a square has all side lengths the same. So because this is H, I will call it C. Let's call it C instead. Let's stay with the theorem, C. Then this would be C by C, so this will be C squared. The area of that box would be C squared. C by C is C squared. So the theorem really literally says that if you take this square and add it to this square, then both of these, their sum will fit into this box very nicely and beautifully and be exactly equal to it. Therefore, A squared plus B squared equals C squared. So that's what that means. And again, if the triangle is a right triangle. So the next thing we want to talk about is a Pythagorean triple. So what's a Pythagorean triple? Well, it's kind of cool. A Pythagorean triple is a set of non-zero whole numbers, A, B, C, that satisfy the equation of the PT. And again, the PT is the Pythagorean theorem. So let's actually write the Pythagorean theorem down, just kind of remind ourselves, what is it again? Oh, it's A squared plus B squared equals C squared. And let's see if these three numbers satisfy the condition. Notice the three numbers are in order from least to greatest. So you want to make sure you do that first, and then just literally plug them in. So we've got 3 squared plus 4 squared equals 5 squared. We want to see if this is a true statement. So this would be 9 plus 16 equals 25. And then we're going to simplify here. We're not going to stop at this step. Do not stop here. Keep going. And then we're going to go 25 equals 25. Now we stop and evaluate if it's true. Is this a true sentence? Yes, it is. Therefore, that's what therefore is when you use math. You use those three little dots. 3, 4, 5 is a Pythagorean triple. Now I'll put Pythag triple. The last part of our notes for today, not examples, notes, is the converse. And isn't that cool how we can use the converse now because we know what converse means? It means we take the hypothesis and conclusion and we switch them. So the hypothesis before was different. Now it's going to be what our conclusion was. So here we go. The converse of the Pythagorean theorem is that if the sum of the squares of the length of a two sides, of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So this is basically saying, hey, let's start off with A and B and C. And if we just find out that A squared plus B squared does equal C squared, then this original triangle that we had really is a right triangle. Okay? So that was different before. Before we started off knowing it was a right triangle, but now we're actually saying, hey, given these three values, this could be a right triangle. So that's what you'll be actually working with, going back and forward between starting with values to prove that a figure is a right triangle, or before, if we back up, starting knowing that a figure is a right triangle, and then actually evaluating those numbers. Okay? Let's look at our first example. Example number 1 says, does the set of numbers form a Pythagorean triple? Okay, so let's start off this problem. We know that 4, 5, and 6 are in order from least to greatest, which is perfect. So we're going to use the Pythagorean theorem, a squared plus b squared equals c squared, and plug in these values accordingly to see if they work. So that will be 4 squared plus 5 squared equals 6 squared, and see if that's actually true. This would be 16 plus 25. Does that equal 36? And again, don't stop here. Keep going. This is actually 41. And now we're evaluating. Is this true? You're asking yourself, no, it's not. So that means no, these numbers, therefore, do not make a Pythagorean triple. And those are supposed to be 3 circles to mean no. Therefore, 4, 5, 6 is not a Pythagorean triple. Our question number 2 says, is this a right triangle? Oh, let's see if it's a right triangle. We want to test out the values. Again, we're going to go a squared plus b squared equals c squared. We're going to plug in the legs, which appear to be 6 squared plus 8 squared. Does that equal 12 squared? So we'd get 36 here, 64 here, and then this would be 144. And again, we don't stop here. We keep going to evaluate it, and we're going to end up with 100. Does that equal 144? Is this true? We're going to say no, it does not, so this is not a right triangle. No. So here we have a question that asks us, well, what is the value of x? Okay, how do we find out what x is? So here's our triangle. And we're going to actually put in a little right angle here because you can't really solve this question without it. So, hey, it's a right triangle, so we know we can use Pythagorean theorem. So I know that x is a leg, so that will be x squared because I don't know it. And then plus 7 squared equals 9 squared. And now I'm actually trying to find out what x is. So I'm going to actually solve this for x. I'm at x squared equals 32, but haven't solved this for x. So now I'm going to take the square root of both sides. And I'm going to end up with x equals the radical 32. And we're not going to simplify the radical today. We'll leave it as radical 32. So that's what x is. Here is our secret hot question. And it says, what's the value of x? There's our right triangle there. What is the value of x? Remember to do work on your Excel skills, Q1 and Q2. Later.